Physics for everyone welcomes you. Today's topic is electric field due to an electric dipole at a point on the equatorial plane. Let us learn few terms. Source charge plus Q, test charge Q naught, the distance between them is R vector and the force on Q naught is F vector. So F vector equals 1 by 4 pi epsilon naught Q naught divided by R square R cap. Now the electric field at Q naught E vector equals F vector divided by Q naught. Now we get E vector equals 1 by 4 pi epsilon naught Q divided by R square R cap. This is a very important formula. Now let us go to the topic. The two charges minus Q plus Q joined by a line, this is called axial line. The midpoint is O. From this midpoint, the two charges are at a distance A each. The electric dipole moment is along the direction from minus Q to plus Q, P vector. Now let us consider a point C on the equatorial line that is a perpendicular bisector of this axial line, which is at a distance R. The point C is at equal distance from both the charges equals to root of R square plus A square each. The angle is theta. Now let us consider a perpendicular plane to the screen passing through the equatorial line, what we call it as the equatorial plane. Let us move towards the right hand side to view this plane. It's becoming bigger and bigger as we go right. Consider a point C at a distance R from the midpoint O of the dipole on the equatorial plane. Since the point C is equidistant from plus Q and minus Q, the magnitude of the electric fields at C due to plus Q and minus Q are the same. Let us remove this plane for convenience. The magnitude of E plus vector and E minus vector are the same, and it is given by the modulus of E plus vector equals the modulus of E minus vector equals 1 by 4 pi epsilon naught Q divided by R square plus A square. Now let us consider only one charge here, that is only plus Q, and no minus Q here. The electric field at C is E plus vector. This E plus vector is along the line joining BC away from plus Q. The direction of E plus vector is along BC. Now let us consider only minus Q charge at A. There is no charge at B. What is the direction of electric field at C? It is E minus vector, and you know that this direction is towards minus Q charge. The direction of E minus vector is along CA. Let us now consider both the charges together, and these two electric field E plus vector and E minus vector superimpose on C and gives a resultant electric field E vector, that is along the direction opposite to P vector. Modulus of E plus vector equals modulus of E minus vector equals 1 by 4 pi epsilon naught Q divided by R square plus A square. So we need another term cos theta, that is given by a formula A, that is adjacent side divided by hypotenuse root of R square plus A square. We are going to use this formula in our later derivation. The point C, where there are two electric field E plus vector and E minus vector, E plus vector and E minus vector can be resolved into two components. One is the horizontal component, another one is the vertical component. The horizontal component is along the negative x-axis, so minus modulus of E plus vector cos theta I cap, and next along the positive y-axis it is modulus of E plus vector sin theta j cap. Next, let us resolve the E minus vector into two components. One is along the negative x-axis, that is minus modulus of E minus vector cos theta I cap, and vertically downward negative y-axis, that is minus modulus of E minus vector sin theta j cap. Now we have to add all these four components to get the total electric field, the resultant electric field at C. When we do the calculation, we know that the up vector and the down vector along the y-axis cancel each other. the total electric field at C, E equatorial vector equals E minus vector plus E plus vector. Look at here, the up vector and down vector cancel, and already these two vectors were resolved into their component. Now we left only with two vectors along the negative x-axis, each minus modulus of E plus cos theta I, another one is minus modulus of E minus cos theta I. All these four vectors been given here. In that, you know that the sign component cancel each other because the modulus of E plus vector and modulus of E minus vector cancels. Equals, so they cancel each other. So we have only E equatorial, that is equal to minus 2 times modulus of E plus vector cos theta I cap. Here we are going to substitute the value of cos theta and the value of E plus modulus, right, from these two equations. Let us first substitute modulus of E plus vector minus 2 times 1 by 4 pi epsilon naught q divided by r square plus a square. Then we substitute the value of cos theta in the next equation. E equatorial vector equals minus 2 times 1 by 4 pi epsilon naught q divided by r square plus a square. In the place of cos theta, let us write a divided by root of r square plus a square I cap. Now, as we simplify, we get E equatorial vector equals minus 1 by 4 pi epsilon naught 2aq divided by r square plus a square to the power 3 by 2 I cap. Here you have a power of half, here you have a power of 1, so 1 plus half becomes 3 by 2. Good, right. And this term 2aq I cap become p vector, right. Since 2aq I cap becomes p vector, E equatorial vector equals minus 1 by 4 pi epsilon naught p vector divided by r square plus a square to the power 3 by 2. Good. At very large distance or much less than a, we have E equatorial vector equals minus 1 by 4 pi epsilon naught p vector divided by r cube. The direction is along the E equatorial direction is along the direction opposite to p vector that is shown by the negative sign here. So this is the diagram and the final formula. E equatorial vector equals 1 by minus 1 by 4 pi epsilon naught p vector by r cube. Let me read again. E equatorial vector equals minus 1 by 4 pi epsilon naught p vector divided by r cube. That tells you E equatorial and p vector are opposite in direction. From equations, the one E axial vector equals 1 by 4 pi epsilon naught 2 p vector divided by r cube. Here the E axial direction and p direction are along the same direction. The direction of the electric field at point on the dipole axis directed along the direction of dipole moment vector p vector, and the next E equatorial vector equals E equatorial vector equals minus 1 by 4 pi epsilon naught p vector by r cube. At points on the equatorial plane, it is directed, that means the equatorial direction is directed opposite to the direction of dipole moment vector along minus p vector. It is inferred that for very large distances, modulus of E axial vector equals 2 times modulus of E equatorial vector. Thank you, children.